Alright, I want to show you one more method for solving problem number 1 using combinations. And again, the problem is to find the number of triangles that we can form with these 5 points on the circle. And in order to form a triangle, we just have to choose 3 points, and automatically, if we connect those up, we'll make a triangle. So we're trying to find the number of ways to choose 3 points from 5, which is a classic combination problem, and we would write that as 5 choose 3. And the way to compute that is to first of all look at the number of permutations. So if we were to choose 3 points, we would have 5 choices for the first point, and once we choose 1, we'd have 4 left to choose for the second point, and then finally we'd have 3 choices for the third point. Okay? And this actually tells you the number of permutations that of 3 things taken from these 5 points. And so a permutation assumes that order does matter. So in this case, this would count A, B, C as being different from A, C, B, and B, A, C, and B, C, A, and C, A, B, and C, B, A. Okay? So the permutation would consider all of these sets of points as being different, but they're really all the same triangle, right? They're just the order is different, and so a combination a combination is what we would compute to if order doesn't matter. And in order to compute the combination, we have to divide out the duplicates. So for every set of 3 points that we choose, we have to divide out the number of ways to arrange those 3 points. Okay? And then the way to compute the number of arrangements is that we would have 3 choices for the first one in the arrangement, 2 choices for the second one, and 1 choice for the third one. Okay? And so, like I said before, this numerator tells you how many ways we can choose 3 points from 5, assuming that order does matter. And the denominator divides out the duplicates. Once we have 3 chosen, it divides it by the number of ways to arrange those points, so that we can get the number the number of ways to choose 3 points, given that order doesn't matter. Okay, so let's see, we can cancel 3 with 3, and we can divide the 4 by 2, and we get 10. So, just like we got before, we have 10 ways to choose 3 points from 5, given that the order doesn't matter. Okay, which will tell you the number of triangles that you can form from those 5 points. And the other way to look at it, like we did before, is to look at the number of ways we can choose 2 points. Instead of choosing the number of ways to find to find 3 points, whenever we choose 3 points, we automatically leave 2 out. So the number of ways to choose 3 points from 5 will be the same as the number of ways to choose 2 points from 5. So we could also compute the combination of 5 choose 2, which would be 5 choices for the first point, 4 for the second, and then we'd have to divide that by the number of ways to arrange the 2 points once we have them chosen. So we'd have 2 choices for the first number in the arrangement and 1 choice for the second. And again, it gives you the same answer we got before, which is 10. Okay? So, if you don't know combinations and permutations, I highly recommend that you take some time to learn that. I'm going to be posting some videos on how to do combinations and permutations. And it's a really good tool to have in your tool belt for solving problems. And this probably wasn't quite enough explanation for you unless it was a bit of a review. So, so there you go. That's how you would solve it using combinations.